In order to add colors to our backgrounds, to our fonts, borders, or whatever, we have to first of all understand how we designate colors in our websites. Now, there are some colors that we've practiced with, like red and green and blue and yellow. There are some colors that we just know by name and we can specify those, but that's really not precise enough for web design. So what we have is a system of specifying colors in two ways. One is called RGB, which stands for red, green, blue, and the other is called HEX or hexadecimal, which is a way of counting by 16. Decimal is a way of counting by 10. Hexadecimal is a way of counting by 16s. The reason we have to do this is because the kind of color we get out of a computer is not the kind of color that you get out of a box of crayons and paper or paint on a canvas. Those are a completely different kind of color in the world of color theory. The kind of color that comes from computers operates off of the principle of reds and greens and blues. Now, in the RGB model, there are 3 positions for each color. The first position, as you see designated down here by red, we would specify how much red do we want. And we can specify that value of anywhere from 0 to 255, which means then that there are 256 possible color combinations. We begin counting with 0. So we could have 0 to 255 in this first position for red, and that would be an indication of how much red we want. 0 would mean we don't want any red at all. 255 would mean we want to maximize the red. The second position is green, and we do it the same way. It's got values of 0 to 255, and the same for blue. So the example that I have here shows how we would actually write this code if we were building a web page. We would say RGB, and then our opening parenthesis, 146, 201, 7. And this color is sort of a lime colored. It's got, on the range of 0 to 255, it's got a value of 146 and 201 greens and just a tiny, tiny bit of blue. Now, the other way that we designate colors is by hexadecimal. And frankly, this is the way that I use all of the time. I hardly ever write RGB, but there are some people who go one way, some people who go the other. This is just a system that I've come to know and like to work with. Now, hexadecimal has a number value that has 6 positions. You can see right here, all 6 positions. The first 2 numbers or letters, the first 2 positions will be for red, the second 2 will be for green, and the third 2 will be for blue. Now, every one of these positions can have a value of anywhere from 0 to F. Obviously, we count from 0 to 9, that's 10 numbers, and then A, B, C, D, E, F, that's 6 letters. So the 10 numbers and the 6 letters gives us a total of 16, and that's what hexadecimal means. We're going to count by 16. And again, this would be where 0 is none of that color, and F would be the maximum amount of that color. And so if we had FF in these first 2 positions, and then 0, 0 for the second position, and 0, 0 for the third position, then we would have the color red, because we would be saying all of red, none green, none blue. Now, a typical hexadecimal value would look something like what we see here, 92C907 with that hash symbol. And by the way, this is exactly the same color as this. All I have to do is go to the web, find me a good converter that will allow me to convert from RGB to hex, and there's lots of them that are out there. Now, what I want us to do is to think about what this means. So we have in the RGB model right here, this is the RGB model. Then we have a position for red that has 256 colors, a position of green, 256, a position of blue, 256. Now, the way we find out how many different possible colors that is, a lot of people says, well, yeah, you just take 256 and multiply times 3. No, that's not the way you do it. You have to square them, or not square them, you have to cube it, because it's going to be 255, or 256, I'm sorry, times 256 times 256. And this is the way we would represent it right here, 256 cubed, which is 16,777,216 colors. That's how many different colors you can create through computers and through your monitors. 16.7 million colors. Now, in hex, remember, in order to express red, we don't have one value, we have two values. And so if we had all of red, that would be 16, and all of red in that second position. And then we had all of green, and all of green, and all of blue, and all of blue. Then over here, since we had to cube, which means to multiply 256 times 3 times, then over here we're going to do the same thing. We're going to take 16, but not 3 times, but 6 times, because we got 1, 2, 3, 4, 5, 6. So we would designate 16 to the 6th power, and again, that is exactly the same number, 16,777,216 colors. So you don't get an advantage in the range of colors by using RGB over hex. It's just that I have found that writing hex is a little bit easier for me, because I can visualize in my brain something between 0 and 16 easier than I can visualize in my brain something between 0 and 256. So for small brains like mine, and for the need for me to keep things short and simple, I think hex is the easier way to go. So let's take a look here at this example. Here we have these cells in Excel. All of these cells, even this one that looks white, I have filled all of these cells to be filled with the colors that are being shown here. So right here we would have the RGB values for red, and again that would be all of red in the first position, which is 255, but no green and no blue. And if you come look at the red color for hex, you can see the same thing. The first 2 positions, remember, FF. F is as high as you can go in the base 16. So FF means all of red, and 00 means no green, and 00 no blue. So this first number here, this 255, this number corresponds to these FF right here in that first position. So let's look at green. Green is no red, all of green, and no blue. And over here we have the hex values. The first 2 positions are red, and we say no red. The second 2 positions are for green, so we say all green. And then for blue, no blue. And the same way down here for blue itself. Here is RGB, which is no red, no green, all blue. And over here we have no red, no green, all blue. Now if we want the color white, then our RGB values would be all of red, all of green, and all of blue, and that will give you white. In the RGB model, working with computers, if you mix all of the colors together, you get white. And in hex, that would be represented by FF, 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 which means all of every possible color. Now, on the other end, RGB, black would be no color at all. Black is the absence of color. And so we would have 0, 0, 0. And over here in hex, we would just have 6 zeros. No color whatsoever. Well, what about halfway in between? Halfway between 0 and 255, that's going to be the number 128. And so for gray, we could use 128, 128, 128. And the hex value for that would be 80, 80, 80. In RGB, if we wanted fuchsia, which would be having all of red and all of blue, but not any of the green, that would give us fuchsia, pretty close to a magenta color, I think. And that would give us in hex all of red, all of blue, but no green. Yellow is all of red, all of green, but no blue. So again, all of red, all of green, but no blue. And then lastly, this last one, close to a cyan color, is aqua, and it is the absence of red, and then you have all of green and all of blue. So again, none of red, all of green, all of blue. This is the way you designate colors for websites. We're going to have to get away from just typing the color :space green. We're going to start designating our colors specifically, because we want to make sure that when our web pages are showing up on people's browsers, that if they have somehow changed the color settings on their computer, we want them to make sure that our colors are being designated in the way that we want them to be shown.